Hi students, in today's video class we are going to learn about ionic polymerization mechanism. Polymerization can take place with the help of ions or with the help of free radicals. Already in the previous video we learned about the free radical polymerization mechanism. In today's video class let us learn about ionic polymerization mechanism in detail. Ionic polymerization mechanism is of two types, cationic polymerization and anionic polymerization. All these polymerization techniques occur in three steps. Initiation, that is the first step, propagation, second step, and the third step is termination. Now first of all, let us learn about the cationic polymerization mechanism. Taking an example of polymerization of isobutylene to polyisobutylene with BF3. This cationic polymerization is one where an electrophile or a proton is involved in the formation or involved in the polymerization reaction, or the chain initiation is done by the electrophile and propagation is carried out by the carbonium ion. If the chain initiation is carried out by an electrophile and if the propagation is carried out by a carbonium ion, then we call it as a cationic polymerization. So for cationic polymerization we can use Lewis acids like BF3, AlCl3, titanium tetrachloride, sulfuric acid and triphenyl chloromethane as initiators. In this example of polymerization of isobutylene to polyisobutylene, we can see the mechanism how it is proceeding with BF3. So BF3 is the initiator which is used to polymerize isobutylene, and this takes place at minus 100 degree Celsius. So when it is subjected to minus 100 degree Celsius, it undergoes polymerization to give you polyisobutylene. As I mentioned you earlier, the mechanism proceeds in three steps, and the first step is initiation. Strong Lewis acid like BF3 is used as the initiator. BF3 or AlCl3 also can be used. Now this initiator BF3, which is serving as the catalyst, reacts with water, that is the co-catalyst, and it forms a added product called H plus BF3 OH minus, which is an added aqua product. Here H plus is the initiator and BF3 OH minus is the counter ion. So in the initiation step, the first stage is formation of the proton, that is H plus. Next stage will be the attack of the proton, that is H plus is attacking the monomer, that is the second step. So this B minus BF3 OH minus can be confined and written as B minus. So when this proton is coming, or when this aqua product is attacking the monomer, H plus is the one which is attacking, breaking the double bond, forming a carbocation. So the H plus comes and attacks the monomer, forming the carbocation. This B minus is equal to BF3 OH minus. This B minus is nothing but it is BF3 OH minus. We have written in a confined form. The next step is propagation. So the carbocation that is produced in the initiation step will attack the second monomer. So during this attack, there is breaking up of the double bond, which is resulting in a product like this. A growing chain will be formed in the propagation stage. So double bond breaks here and the positive ion comes to the new monomer and B minus is coming to this end. Now the repeating units, it is written in square brackets the whole n times. The third step is termination. Termination can take place in two ways. Termination is the end of the reaction. So the growing chain comes to an end, giving the byproduct out, that is H plus BF3OH minus is removed out, forming the dead polymer or end of the product. This can occur in two ways. One is the ion pair precipitation. In ion pair precipitation, donation of a proton takes place from the polymer to the counter ion. Okay, there is donation of the proton from the polymer to the counter ion is taking place, resulting in the formation of a double bond in the end product, and thus it arrests the growth of the chain. So H plus B minus is obtained. B minus is nothing but it is a BF3 hydrate. This termination reaction also can occur by a process called coupling. In coupling, there is formation of a covalent bond between the carbonium ion and the counter ion. So there is a covalent bond which is formed between the carbonium ion and the counter ion. Thereby the polymerization reaction is coming to an end and BF3 is removed out. So this is how the cationic polymerization is proceeding. Let us learn the cationic polymerization using another one example also. That is, polymerization of styrene can take place by cationic mechanism with AlCl3. Actually, this type of polymerization takes place when there is electron donating groups. Okay, so this cationic polymerization also takes place in three steps. First one is the initiation. Initiation involves the formation of the chain initiating species. AlCl3 is the initiator or a catalyst which is reacting with the co-catalyst, forming a adduct like this. Now this is a reagent that is going and attacking the monomer. So here in styrene we have the phenyl group. The presence of a phenyl group or presence of methyl group enables the cationic polymerization to take place, or these groups, the presence of methyl group and the phenyl group, stabilize the formation of the carbonium ion. A stable carbonium ion is obtained because of the presence of the phenyl group or the methyl group. So the first stage here is the initiation. In initiation, there is a formation of the chain initiating species where AlCl3, that is the catalyst, reacts with water co-catalyst, forming H plus AlCl3 OH minus. Now this group attacks the monomer. The monomer is styrene. During that attack, the double bond in the monomer is breaking. The proton adds to this carbon, forming CH3 CH CH5 plus. This is the carbonium ion, or this is the chain initiating species. The second step is the propagation. Propagation involves the growth of the chain initiating species by successive addition of monomers to the chain initiating species. So one by one the monomer adds to form a growing chain. So during this addition of the monomer to the carbocation, there is breaking up of the double bond, and the positive charge shifts to the newly added polymer. This positive charge shifts to the newly added polymer. The double bond breaks here and it is utilized in bonding this monomer with this carbocation. So this is the growing chain that is formed by propagation reaction. The last step is termination. So termination of the growing chain involves removal of the catalyst by addition of proton to the counter ion. A proton from here adds to the counter ion. So the counter ion is AlCl3OH minus, which abstracts a proton from here, thereby a double bonded unsaturated end product is obtained, arresting the growth of the polymerization or resulting in the macromolecule and eliminating the counter ion out. So this is how the cationic polymerization proceeds. Thank you for watching.